Okay, let's go over exam 3B, number 1, right? So we have this rational function, it's given, and we want to take bunch of limits and find horizontal and the vertical asymptotes, right? So let's do that. All right, so when we are taking a limit as x approaches infinity, we can actually focus on the leading terms. So leading term on top, and also leading term on the bottom, right? So we can write it as, right, limit as x approaches infinity, right? So you have 2x squared is the leading term on top, and x squared, which is the leading term on the bottom, right? Then we can ignore the rest of the terms, right? Then you can see that x squared and x squared cancel out. So you have limit of a constant 2 as x approaches infinity, right? But the limit of a constant is the same constant, so it's going to be 2, right? Let's look at the part B, right? Now x approaches 3, right? So in that case, we're actually looking at this guy. This is just a factored version of the same function, right? Before we take the limit, you can see that there's a common factor, which is quantity x minus 3 on top, and there's x minus 3 on the bottom, so we can cancel them out. So we have limit as x approaches 3 from the left, right? What's left is 2x plus 1 on top, and x plus 2 on the bottom, right? So first thing you do is just plug in. So you're going to get 2 times 3 plus 1 over, right, 3 plus 2, right, which is going to be, right, 2 times 3 is 6 plus 1, 7 on top, over 3 plus 2 is 5. So 7/5 is the limit, right? Part C. Now x approaches 2 from the positive side, right? So let's do that. Similar to part B, we can just use the one without the x minus 3 canceled out. So x approaches -2 from the right, right? So what's left is 2x plus 1 over x plus 2, right? So plug in. So 2 times, right, x is going to -2, right, plus 1 over, right, -2, right? So this one you have to be careful, and we're approaching from the positive side, right, plus 2, right? So this is going to go to, right, 2 times -2 is -4, plus 1 is -3, over, right, bottom is actually going to 0, right, but we have to be careful, right, -2 from the right. So you can think of this as slightly larger than -2. So for example, it's -1.9999. Then you're adding 2 to it, so it's going to be slightly positive, right? So which means that, okay, so if you have a finite number divided by something very close to 0, it's going to have a large magnitude, right? Negative number divided by positive number would be negative. So it's going to go to -infinity, right? Part D, we want to find all horizontal and vertical asymptotes, right? So you can see that here A is going to give you a horizontal asymptote, horizontal asymptote. Since limit of the function at infinity is equal to 2, you can do that as x approaches negative infinity, still it goes to 2. Right? So y equals that number is the equation of the horizontal asymptote. Right? And if you look at the part B, right? Part B, limit actually does not go to positive infinity or negative infinity, which means that it is not a vertical asymptote. So in this case, x equals 3. X equals 3 is not a vertical asymptote. So there's no vertical asymptote there, right? But part C, right? The limit goes to negative infinity as x approaches negative 2 from the right, so which means that we have a vertical asymptote at x equals negative 2. So its equation is x equals negative 2. Right? So this is the equation of the vertical asymptote. All right, that's it. I hope that this was clear.